Hey guys, welcome back to the channel. This is a physics buddy. In this lesson, we'll be starting a different unit, impulse and momentum. This is going to be the first lesson. In this video, we'll be discussing about impulse and also what is impulse momentum theorem and how does it works. Apart from this channel has already covered different units as per the honors physics curriculum, AP physics curriculum, as well as all the board related physics. Do check them out. Do watch this video for a few minutes to understand that how these valuable concepts are for your exam. Let's get started.
All right then. So let's start today's session. So basically today we are going to start unit 6. This unit 6 is basically the application of Newton's laws of motion. Here we are going to discuss about impulse. We are going to discuss about momentum, and we also discuss about all the phenomena associated with it. Like for example, we talk about conservation of momentum here as well, which is the very most important topic. If you understand that what is conservation of momentum, then we'll be able to talk about collision as well. So we have to discuss each and everything in detail. Also, as your curriculum is also only limited to those phenomena which doesn't involve use of calculus, so we'll make sure that we stick to that part only. So before heading towards what is impulse and what other things are, let us try to recall what is Newton's second law of motion. So tell me, what is Newton's second law of motion?
F
What do
equals
you
ma.
understand? That is a result of second law
Oh,
of motion. But what was the statement of the second law of motion? Tell me that.
what it actually is. Was it acceleration is like I guess proportional to the force acting on it.
No, you won't say it like that. According to Newton's second law of motion, rate of change of linear momentum is directly proportional to the external force applied.
Oh,
The
okay.
rate of change of linear momentum of an object is supposed to be directly proportional to the external force applied. So we already discussed about all the key points here, but there are few things that we can derive from this law once again. So the one such thing is impulse. So we'll use this relation only. So as we know that external force acting on a body is directly proportional to its rate of change of linear momentum. This rate of change of linear momentum can be written as delta p by delta t, where delta p is supposed to be the change in momentum. Although we do discuss about what is change in momentum and we do discuss about what momentum exactly is. So let us try to remember or memorize all those things and then we'll move towards the term impulse. So as we already know, if we talk about momentum, so momentum is a quantity which actually express or you can say represent the quantity of motion possessed by the body. So whatever motion an object is going to do, this thing is basically represented by its momentum. So I already explained you this thing that suppose there was an object and that object was moving with certain velocity v initial having some mass m. So here initially we can say as the object was moving, so it must possess some momentum and its quantity of motion is represented by this fact that momentum is equals to product of mass and its initial velocity. If suddenly an external force is applied onto the object in the direction of velocity, so we will observe that after the application of external force, this object might feel some change in its momentum by actually having change in its velocity. So if the velocity or momentum, any of the one changes, it might possess change in its momentum. So here what we observed simply that force is something which is directly proportional to delta p by delta t. So here F is equals to delta p. Delta p can be written as momentum final minus momentum initial over change in time. So F is equals to mv final minus mvi over time. So from here we can say that force into time is nothing but mv final minus mv initial. So this is the relation that we have to consider here and that we have to talk about. So Newton's second law of motion not only say this thing that external force is going to change the momentum, but it also says that if there is a small force acting on an object for a small period of time also, like for example, that suppose there was an object traveling at a certain speed and suddenly it faces a wall. So due to this wall, when this object is going to hit the wall, it is going to rebound with some velocity, which is supposed to be, we can say Vf, V final velocity. So here what we observe that due to this contact with the wall, there is a change in velocity of the object. So here we can say due to this short period of time of contact, object's momentum changes. So here what we can say here that this wall certainly has applied some force on the object, and because of which the whole momentum of the body changes as well as its direction. So what we can say here about these objects, that because of this velocity and the motion, when the object hits the wall, its velocity's direction changes. If we assume that its velocity's magnitude doesn't change, but still its direction has changed. So due to that contact for a very short period of time, we can say there must be some force which has acted upon the object and it changed its momentum. So the term which we actually have to discuss here is impulse, and impulse is basically a quantity which represents the quantity of force acting on an object for a very short period of time, which is responsible for change in its momentum. The impulse is represented by I vector, or sometimes we use J vector also. So it is a quantity which represents a force acting for a very short period of time. A force acting for a very short period of time. And this short period of time is can be like very small, like 0.01 seconds, like some milliseconds. So these kind of numbers, these kind of time for which the object has experienced force, that small force can also change the momentum completely of the object. Let me give you some examples here to understand the physical importance of this particular relation, particular term. So just assume that there is a player and they were playing cricket. So what happens here is the bowler balls the ball and the batsman hit the ball. So when the batsman hit the ball, what the batsman exactly does? The batsman applies the force on the object for a very short period of time. So when the batsman applies the force for a very short period of time, that small force is actually capable of changing the momentum, changing the whole momentum of the system. And that change in momentum is represented by impulse. So in the very first example, we can assume a batsman hitting a ball. So whenever a batsman is hitting a ball, it is actually changing its momentum.
Mm-hmm.
So now when a batsman is hitting a ball, it is actually doing what? It is actually changing the momentum of the ball. And when the momentum of the ball is being changed by some external force, like for example, this was the ball, this was the bat of the batsman. The ball came this way, batsman hit it, and it went this way. So initially, the object has certain velocity in this direction. Finally, again, object has certain velocity, but the direction of the velocity has changed. So what exactly has changed here is its momentum. So there must be some change in its momentum. So what we have to understand is if there is an object and that object experiences some force in such a way that that force acts for a very short period of time and it changes its momentum completely. So impulse is defined as a force that is acting for a very short period of time. And impulse is given by force times t, that is force times time. Again, it is a vector quantity, and this vector quantity must have direction. So whatever direction this force has, that is going to be the direction of impulse. Also, we can talk about its unit. Its unit is going to be Newton seconds. Let us try to understand this by another example. And that example is, we can assume a fielder trying to catch a ball. So what happens here is, whenever a fielder tries to catch a ball, what he exactly does? He used to take his hand a little backward. Whatever hand a fielder might have, what he used to does is, he used to take it a little backward once the ball is approaching towards the fielder. Now, why it used to do that? Because it has to change the momentum of the object completely. Because that momentum of the ball needs to be changed completely, and that momentum change is only done if there is an external force applied by the person. So this external force which a person or the fielder is going to apply, it must be in such a way that it act in this direction, or you can say in the direction of the ball in which it is coming. But when he used to pull his hand a little backward, what you observe, the ball velocity is being reduced slowly. And what happens if you try to catch it by keeping your hand so still? if you're trying to catch it by keeping your hand so still, so there might be possible that ball might just slip out of his hand, the ball might not settle into its hand, or so many other possible possibilities are there. So what we have to understand from impulse is that impulse is a quantity which actually expresses that if a force acting for a very short period of time is capable of changing the momentum of the body, that whole thing is called impulse. So we just give the name, we just give the quantity. That impulse is something force into time.
Okay.
What else we have to understand from here is that suppose we have to find impulse. So impulse can also be find out using area under FT graph. So we have FT graph of any type, like for example, there is a force and there is a time. So how or whatsoever the way the force is changing, so the area under the curve is going to give us what? It is going to give us impulse. So this area under FT curve is going to give us impulse. So this is also one such thing that you need to remember. There might be some cases where you have few questions to do from this particular part. So once again, an impulse is a quantity which actually defines that how much force is acting for a short period of time. Now that is the very key condition. The time period should be very short. A very short period of time period, a very force acting for a very short period of time is capable of changing the momentum, and that whole thing is known as impulse. So now let's just move back towards the equation of second law. So equation of second law says that force is something which is directly proportional to rate of change of momentum. So from here we got that force is something which is directly proportional to delta p by t. So if you just put this t here, so we get that F times T is nothing but delta P. So this F times T is something which you already understood that it is impulse. So impulse is also defined as change in momentum. So this is also one such thing which we'll be using in so many numericals. We'll be doing some numericals here considering the vector part only. So we'll understand that how all these things can be calculated. So this particular relation explains that impulse is also known as the rate of change of momentum. Or you can say impulse is also defined as rate of change of momentum. And this whole thing, this whole statement is actually a theorem which is known as Impulse-Momentum Theorem. So if any time if anyone asks you that what is Impulse-Momentum Theorem, you just need to explain that Impulse-Momentum Theorem is I is equals to delta P, where this I is impulse and this impulse is nothing but change in momentum. So this equation is also a part of Impulse-Momentum Theorem. That is what you have to understand. Now, as we told that this is a vector quantity, so the whatever vector quantity we are having, it must have some direction. The direction of this impulse is always in the direction of change in magnitude. Always in the direction of change in magnitude. Now, why I am saying this? Always in the direction of change in momentum. So let us try to understand that how the impulse direction is actually being calculated or defined. So in order to do that, we need to understand the examples only. And to understand it better, let's move towards a problem. And that problem is going to help us understand that how impulse and its direction has been defined. So this is going to be a very important question. If you understand this question well, and if you got to know that how everything is being there, this topic is going to become super easy. Like again, this topic involves only vector application. If you have that knowledge of vector, prior knowledge of vector so well, this topic is going to become very easy. So how we supposed to do this? So question says find impulse imparted by the wall on the ball in given cases. So we'll be starting it from a very simple case, a very easy case, and then gradually we'll try to increase our level of understanding. So the first case, the ball was traveling with some speed, 20 meters per second, having mass 150 grams. What happens here is this ball was traveling in a straight line, finds that there is a wall. So because of this wall, what is supposed to get happen? The only thing which can happen here is the ball will rebound.
Yeah.
So I assume that ball, the question says the ball has rebounded with the same velocity in the opposite direction, exactly opposite direction. This is what the question says. So we have to find that what is the impulse imparted by the wall on the ball. That is important. How much impulse is wall imparting on the ball? again, remember the external body which is not moving or which is actually changing the momentum of a given body. That body is actually something which impulse momentum. So it imparts momentum. It is not that body which is moving. So that is also we need to keep in mind. So here we have to understand that how impulse is being calculated. So as we understood this particular fact that impulse is a vector quantity. So I should write it as I vector must be equals to delta p vector. And how we got this equation? If you have to write the solution of this part, we will say according to impulse momentum theorem. So this is something we have to mention that this relation is something which we got from impulse momentum theorem. And again, everything came from Newton's second law only. Remember this part. Second law of Newton is the cause of half of the mechanics. Half of the mechanics works on this Newton's second law. So wherever you are going and whatever you are talking about in physics, in mechanics, that is must be or you can say might be possible that it might be derived from the second law of motion. So here the according to impulse momentum theorem, we can say I must be equals to delta P. So let us try to figure it out that what is impulse here by simply putting the values in this relation. So let us try to simplify it. So here
Yes.
I is something we have to find. So delta P is what? Change in momentum. And change in momentum is written as final minus initial. If you try to explain what is final momentum, so again, you are dealing with vector quantity, so you have to mention the directions. Now see this particular point that how we're supposed to mention the direction. Next question is something which you're going to answer. So initially, this ball is moving in x-axis, or I can say positive x-axis. So its direction is represented by I cap. Can I say that?
Yeah.
Similarly, when it rebounds, it is started moving in opposite direction of this I, that is negative x-axis. So I can write its direction as negative I cap. So that is very important. This is the direction of velocity. Remember, we are writing the direction of velocity here. So what is momentum final? Momentum final must be mv final minus mv initial. So mass is something which remains constant because we are not observing any change in mass here. So we'll keep it as constant only. So I is mass v final minus v initial. So again, a very simple thing. Mass is 150 grams. So always remember whenever you are solving any physics problem, the units of each and every quantity we are using, it is supposed to be in SI units. So M is going to be 0.15 kgs. V final is something 20 negative I cap. So we have to mention the direction. Negative, I should not write negative first. We should write 20 negative I cap like that. Minus, what is the initial velocity? It is 20. What is the direction? I cap. So we can write it this way. It is going to be 0.15. This negative sign will come forward. Negative 20 minus 20 whole I cap. Did this thing make sense? That how the direction is being explained here?
Yeah,
So
makes
we can simply say that I is something which must be having impulse is something it must be having I cap direction initially. So once we solve this, so 0.15 times minus 40 I cap. The impulse is a vector quantity. Negative sign doesn't make any sense to the magnitude. So negative sign must be belongs to the direction. So here we can say it is going to be negative 6, negative 6 I cap. Or I would write it as 6 negative of I cap. So this is going to be the impulse in this particular case. And if we talk about its unit, what its unit is going to be, we can write Newton's second. Also, we can write this particular unit, which is called the unit of momentum. What is the unit of momentum? Kilogram meters per second. This is how you're supposed to find out the impulse in this case. I hope this makes sense.
yes.
All right, so let me just give you another part, another case. And in this case, you have to tell me the answer. So the
Alright.
question says that there is an object. It was initially traveling with 20 meters per second, having mass 300 grams, strikes the wall, and once it's rebound, the velocity reduces to 10 meters per second. Obviously, mass remains same. So this is the first part of this first case. Second case, the second part says that the ball after collision or ball after hitting the ball after hitting the wall, just drop dead, just drops dead. So what is the impulse in each case? Think about it and tell me.
Alright.
Solve it well. and then tell me the answer. Again, directions are important because we are dealing with vector quantities.
For part 1, I got 9 newtons to the left.
9, what is the unit?
Newtons? I know. Sorry.
Mm,
How do you say it in like in
this
die?
kilogram meters per second or Newton second. Any of these you can use.
9 newtons second to the left.
Yeah, okay. So let us see this because I don't think so it is correct. So I must be delta P is P final minus P initial. MV final minus MV initial.
Oh, I
So
did 0.
initially, yeah, it should be 0.3 times 10, but it is going in negative direction, so I'll take it as negative. All right. Yeah, so make sure the units are you have used well, and also you have defined things well. Although that's correct. What about the second one?
The 6 newtons second to the left.
6 Newton seconds to left. Yeah, all right. That's also correct. So you got it pretty well. That's
Mhm.
amazing. Now let's just raise the bars and try to make situation a little difficult.
Okay.
So the question says the case third, we can say. So this is the case third. Now what happens here is again there is a wall. The ball was initially traveling, or I can assume having mass 100 grams, initially traveling with speed 10 meters per second. For the simplicity of calculation, a simple data. It went in such a way that it hits the wall. But now this time the ball rebound at 30 degrees with 15 meters per second of velocity, obviously having same mass. Now you have to find the impulse. Take your time and tell me the answer. Again, remember vectors. We're dealing with vectors, so whatever we have done with vectors before, we can do it here as well.
Well, it's the same. You just do 0.111. So 2.3 newtons second to the left.
2 point what?
2.3 newtons second, or yeah, newtons seconds to the left.
Are you sure?
Let me check it again. Because VFX equals negative 15 cosine 30 degrees.
Yeah, so cosine 30 is what? Root 3 by 2.
Yeah.
And initially the momentum is traveling in this direction is supposed to be 0.1.
Yeah.
So you just have to add them in order to get change in momentum in x direction. So
But
we can
no, you
write
have
it
to
as
do
delta px.
no, you have to do negative 15 times square root 3 by 2.
So what you get?
Negative 13. And then you substitute that into the impulse
You got
equation.
negative 13.
Meters per second. Yeah. For VFX.
No. 13 is not possible. Just do it again. 0.15 times root 3 over 2. Do it again and tell me.
Okay. Root 3 times. Well, it's negative 12.99, and then it's rounded that.
Hmm. Negative 4.99. Are you sure? Is it like 0.4.9, 0.499?
Isn't it just negative 15 times 0.866?
Okay.
Or, yeah. Because why did you subtract negative 0.10? Oh, because
No, they are in the opposite direction. So you just have to consider direction as well. And this will make it positive. So it is going to be MV cos 30 degrees, as the angle is MV 30 degrees. So mass is 100 grams. So 100 grams is basically going to be 0.1 kg. If you multiply it with velocity, we'll get product of MV. So we're going to have 1.5. And if you multiply the same with cos 30, so we'll get 1.299.
yeah.
So we should write here 1.299. And similarly, we add 0.1 to it. The whole answer is going to be negative of 1.399. So that is the momentum in x direction. Now, we haven't solved the question yet. We just found one thing, that momentum in x direction is supposed to be 1.399. Similarly, the system might have momentum in y direction, and the resultant of these two will going to give us the net change in momentum. Are you getting it?
Yeah.
That net change in momentum is going to be calculated by using the resultant equation. And the resultant equation was a square plus b square plus 2 will be cos theta, where cos theta is supposed to be the angle between the vectors. So here we can write delta p as delta px square plus delta py square whole under root. So that is the reason why you have to individually find this px first, then py, then you just square both of them, add them, take root, and you get the delta p, that is change in momentum. So we are not done with that. What is the value of py? So py is 0.15. Or I should have written 1.5. That is the one making confusion. So 1.5 times sine 30, and sine 30 is supposed to be half. That is coming out to be 0.75. So one is 1.399 and other is 0.75. So delta P in this case is going to be, we just have to square all of them
Okay.
and add them. So just do it and tell me what we are going to have.
Mm. Three. Is it all equal to 1.59?
What exactly?
1.59.
Hmm. So we just have to understand that how this thing is being calculated. So we got delta P. This means we got impulse, and impulse is going to be 1.59 Newton seconds. We can write off kilograms meters per second. So we just have to understand that how impulse is calculated by simply calculating the whatever change in momentum is there, depending upon the case, to be precise. So let me just give you one last question on this particular part. And if you did it on your own, it means you understood the topic well. So this is a ball once again, and there was a ball of 450 grams mass traveling at 15 meters per second, hits the wall at an angle of 45 degrees and rebound at the same angle with the same velocity. Rebound at the same angle and at the same velocity. Question is find impulse. So if you get this question, this means that you got to know what impulse is exactly. And there are some other section of questions as well on impulse where we were actually given with the force that suppose the object suffers the force of 90 newtons and the point of contact or the time of contact what like say 0.010 seconds, 5 seconds. So in that case, if you have to find out impulse relation, you multiply force and time. But that is
Mhm.
pretty simple, but that is pretty simple thing. So this is the concept which actually makes it a little difficult. But yeah, if you have good understanding of vectors, it becomes automatically very easy. So this is how you are supposed to think about it. Solve
Okay.
it and tell me what we are supposed to have.
All right.
Yeah, sure. Just tell me one thing.
Yeah.
So how do you feel about physics now? Like what physics is exactly for you now? How much you're able to understand it and how much it feels like is there anything which you feels like that this is something which I can't do?
Um.
How it
No.
exactly feels about physics? So just try to explain.
Yeah. I'm understanding a lot better than before, so these classes are definitely helping. But
No,
yeah,
no, no.
right.
I'm not asking from the this class point of view.
Uh-huh.
I'm asking what you exactly feels for it. Like
Like.
is like something let me tell you some of students' ideology that what the exact thing. Some students are like this kind like they feels like all right, we can do it. We understand most of it, and when it comes to exams, we'll try and we'll do it. We know that. So we are not that much connected to the subject. We need to do it, we'll do it at the time of requirement. We'll get passed into it and we're good to go. We'll focus on something else. Some students have this kind of ideology, whereas some students are very curious, so they just want to be like know everything, what exactly is going on. Why? But on paper, when it comes to giving tests, exams, they don't perform well because their curiosity is something which doesn't let them stick to the path. They divert a lot, and the curiosity just take them to the new path, we can say. So it affects their academics a lot. They don't understand how to solve problems much. Some students are like this, whereas on the other hand, we do have some students which are like that I have to excel in it. So I have to make everything very perfect. So some students are like, okay, so we need to know this topic. I'll try to make sure that I understand 100% of this topic. And any question of my level, my academics came into me, I will be able to solve it. Like related to my curriculum only. Some students are like that. That I want to be that much perfect in the subject in marks also in whatever things are there. It's fine. I'm curious, but I'm not that much into it. Like that, like at this point of time, I won't think about to make time much, and I don't think about anything which is unrealistic as of now. But yeah, you can think about it. If curiosity will allow you to think about it, that is completely fine. But academics are going to affect a lot. You need to be very focused about what you are doing. So the question is, what you exactly feels about physics? Like, what category of students you would say that I came into? What kind of student I am?
Yeah. I think I'm more of wanting to excel in the academic part. And yeah, of course I'm curious. Like that's very interesting, but I think I prioritize, doing well in the exams rather than knowing more and more information.
So do you feels like that you are able to solve any question came to you from your curriculum as of now, like whatever you have studied till far?
Yeah, I do think so. Yeah.
Okay. So solve this one.
Mhm.
Again, this is a vector quantity. So the application complete a great application of vectors. We're going to revise here once again. So initially the object was moving in this direction. So we can say that the momentum must be in this direction. So
Mhm.
this momentum must have two components. One component should be drawn this way. downwards. Another component should be drawn this way towards right. Similarly, when it is going back, the direction is this. So this is going to the direction of momentum. So if this is going to the direction of momentum, the direction of momentum in y-axis is going to look like that, and in x-axis is going to look like that. So what
Mhm.
we have to understand here is that this delta px is going to be negative of 2mv cos 45, whereas delta py is going to be 0.
Mhm.
So
Oh.
as we can see that the net change in momentum lies only in x-axis. So the impulse will also lies in x-axis, that too in negative direction. So towards left, you can say. The direction of impulse is going to be towards left. And similarly, the value is going to be calculated using this particular relation, which I only got from what? A square plus b square.
Mhm.
And you can say uh, p cos 45. So it is going to be p cos 45 here, p cos 45 here. You're going to add them because they are in opposite directions. So impulse is going to be the sum of these two. So 2 p is something which is mv cos 45. That's it. So just solve it and tell me what is the value of I impulse.
Negative 9.54. So
Mm,
in that direction.
yeah.
I mean, left direction.
Yes. So this is how you're supposed to solve these particular type of problems based on impulse. And that is all that you need to learn. And just go through the textbook and see some problems. And just make sure you try as many as you can. And if you find any difficulty in any problem, just let me know. Although I believe that most of them must revolve around this particular phenomenon only, or you can say this particular concept. So you need to understand that how you should be applying this thing. All right, then let's keep it till here only. And see you in the next class.